Physics IIT Patna since 10th December 2008 as a faculty member at the Department of Physics. Prior to this assignment, I was working at Center for Nanotechnology IIT Guwahati, where I gained lots of experience. Prior to that, I was a research scholar at the Department of Physics IIT Guwahati. Before that, I completed my MSc in Physics, BSc Physics Honors, and my all other schoolings from Odisha. Mostly my expertise is on condensed matter physics, although I work experimental condensed matter physics, but also sometimes I try to model the experimental results as well as theoretical modeling to understand the matter at the solid form. In passion, I am a teacher. I started my teaching just after completion of my +2. Some students approached me to teach physics and mathematics. Since then, I have not stopped. I have taught the students in all levels, starting from class 7 to PhD as well as postdoc. So with that experience, I understand. As a physics teacher, first of all, you should know the mathematics. If you go back to the biography of great scientists, I cannot take all the name what I have gone through, but definitely I will tell some of the common names like Dirac, Einstein, Madame Curie, and so on. And they were very strong in mathematics, and also they have mentioned in their biography that's what they could success in the life. So according to me, one can be a good physicist or good physics teacher only if he knows mathematics well. Moreover, I was very lucky to be associated with some of the great teachers who has given me education by which today I am standing on my feet and I could pass some knowledge on physics or the physics formulation to others for carrying forward in a long way. And on that I can recall, and one of my teachers said, Manoranjan, if you educate a person who does not know physics, that defines your teaching quality inside you. If some good students are associated with you, definitely they will do their job. From that day I did not look back, and always I try, even a guy who does not know anything, I try my best level to reach the physics. In that way I have attended lots of school presentation where I teach how to read physics, how to learn physics, and for that I got a lot recognition, not only from the students, also from the school and college teacher community, and that also it has been reflected how I do the physics teaching. I go down to the basic level and teach physics. Moreover, at the last I will tell that not only physics teacher, a teacher should be very polite. That does not solve the purpose of a teacher, and teacher should maintain the truth in his life. If I speak a wrong physics or wrong mathematics or anything wrong, whatever explained in the book and the formulation, what happens, the student carry forward and it multiply like anything. So I will thank to my teacher who taught me this, even if I ask some small thing to him during my tenure of PhD. Always he was telling nicely one sentence, I do not know, even if it is very small thing. I did not understand, later I could understand what should be a teacher. That is the best quality, because you should be always very careful to speak a truth or the mistake. You should barricade it and you should have the all information before speaking the formulation of science. So when I understand that, even if a class 1 student asks anything, I keep my politeness to say that I do not know. If I don't have any, if I do not have all the information at that time, or I am not able to recall all the information at that time, or the formulation of the physics or any other subject. At the last, I would like to mention that I try to read other subjects, because there is no limitation in one subject. It should be extended to the other subjects so that you can connect and convince to the students by different examples and physical phenomena happening around. So that defines a teachership on me. I feel proud that I am in this profession, because here I can leave something in this world which will carry forward for the long time. That's what I keep my passion as a teacher. And first of all, I try to become a good teacher, whatever may be the level of teaching. It may be undergraduate, maybe postgraduate, or maybe postdoctoral, that means post to postgraduate. So I try to teach everybody in a different level the same subject, and for that I spend the time to gather the information. Thanks to listen me, and I hope it will inspire me to go forward in this point.
Small lecture, we are going to understand the behavior of electron and hole inside the nanocrystalline semiconductor. So as we are going to understand, we are going to formulate it. Let us go back to the 19th century and 20th century. If you look into that, from Newton's to Hygiene and Dirac, de Broglie, and people were working how to formulate in the physics, and they found that then there was a competition between the particle nature and wave nature, and de Broglie hypothesis till today we have not accepted it as a law or something, but it is still a hypothesis, but it gives a better, very good physics to understand the materials also. So he gave a theory, and due to that we could understand the behavior of the material. So we are going to apply it a simple theory and to understand what happens to the electron and hole inside the nanocrystalline semiconductor. So our topic is today we are going to understand electron and hole behavior inside the nanocrystalline semiconductor. So, as we discuss the de Broglie hypothesis, what he said, the wavelength of any particle can be written as h by mv, where h is the Planck's constant and its value is 6.62 into 10 to the power minus 34 joule second, and the mass, m is the mass of the body and b is the velocity of the body. Now we are going to use this simple formula and understand the behavior of electron and hole inside the nanocrystalline semiconductor. Now let us understand what happens to the electron and hole inside the semiconductor. Inside the semiconductor, let us have a simple picture, and there is an electron. So in case of the semiconductor, and there will be lots of the lattice, nothing but the atoms, and this nearest neighbors, if you took it and I take a very simple configuration of the cubic crystal in two-dimensional, the atoms are sitting at the corner. If you look into this picture, the electron has the interaction with the atoms. So if you look to this configuration, you can easily understand that now the electron is bound at the lattice side. So if the electron is bound inside the lattice side, what happens? This electron have a effective mass inside the semiconductor. We call the effective mass. And so the electron has an effective mass inside the semiconductor, and which is always less than the rest mass of the electron, which is nothing but the m0. The rest mass of the electron m0 is, right, this is 9.1 into 10 to the power minus 31 kg. What do you mean by the rest mass? When electron is free from any interaction, that we say that it is the rest mass of the free electron. This is the mass of an free electron. But here the electron is bound inside the semiconductor, so it has a effective mass. So the velocity of the electron, again due to the bound nature of the electron and its velocity also modified, it is not exactly equal to the light velocity. Its velocity is v is less than the velocity of light, 3 into 10 to the power 8 meter per second. So now let us take a typical example of a semiconductor where the mass of the electron, effective mass of the electron is equivalent to 0.1 of the m0. Due to the bound nature, it is a typical value of the semiconductor, and the velocity is 10 to the power 5 meter per second. Similarly, the effective mass of the hole is a little high because the hole is always at the lattice side, electron is in the other side. That's why the hole effective mass is lower than the electron, and that mass is m whole star, and we write it 0.4 m naught. But the velocity of the hole is nearly equal to the electron velocity, that is meter per second. So now we have all the information. Let us find out what is the typical de Broglie wavelength for the electron and the hole inside the semiconductor. If you calculate the wavelength of the electron inside a semiconductor and you put the value 6.62, that is the Planck's constant joule per second, and divided by effective mass of the electron 0.1 into m naught is 9.1 into 10 to the power minus 31 kg, and your velocity is into 10 to the power 5 meter per second. And if you calculate it, and you get the close to 73 nanometer. Then now you calculate the de Broglie wavelength for a hole, and if I put it, so de Broglie wavelength for a hole, and what you get, and if you put the value 6.62 into 10 to the power minus 34 joule second by 0.4 into 9.1 into 10 to the power minus 31 kg into 10 to the power 5 meter per second. So what value you get? And this value is close to 18.2 nanometer. What you get? Now you think this is a semiconductor, particular semiconductor. If I reduce its size below 73 nanometer, so what will happen? The electron inside it cannot form a wave. They will confine inside the semiconductor. So we say that it is a weak confinement, because here only electrons are confined, and in the semiconductor both hole and electrons are there, still the holes movements are there. Then when you say that this material is less than this 18.2 nanometer, we say it is a strong confinement, because in this below this length and both electron and hole are confined, basically the material becomes the fully insulated. So now in between we say it is a intermediate confinement. So how the length scale is defined, the nanocrystalline length, when length of the nanocrystalline material is less than 73 nanometer, or you can say the wavelength of the electron, de Broglie wavelength of the electron, or when this length scale is in between, L is less than 73 nanometer but greater than 18.2 nanometer, we call it is the intermediate confinement, or you can write it the de Broglie wavelength of the hole, and which is less than the length of the material and is the less than the wavelength of the electron. Then the strong confinement, it is defined as length of the material should be less than the de Broglie wavelength of the hole of particular semiconductor. So what we get in pictorial, if you put, and the length scale, if you have a material and it has a strong confinement length, and we say that the radius of length of the material is the lambda electron, but basically it is the de Broglie wavelength for the electron, and there will be a confinement length for the lambda wavelength of the hole, and we say that it is a strong confinement, and we call it is a intermediate confinement, and we say it is a region of the weak confinement near the 73 nanometer, weak confinement region. So let us take one example of the material aluminum arsenide, and in case of the aluminum arsenide, and in this material the effective mass of the electron is equal to 0.15 m naught, and effective mass of the hole is nearly equal to 0.5 m naught. So now the velocity of the electron and hole, we say that nearly equal to, for both the cases, electron or hole in both the cases is nearly equal to 10 to the 5 meter per second. Now use the simple equation of the de Broglie wavelength and calculate the lambda E, that is de Broglie wavelength for the electron in case of the aluminum arsenide, and you get a value of the nearly equal to 48.4 nanometer. Then if you calculate for the hole, and you get it nearly equal to 14.2 nanometer. So for the aluminum arsenide, the weak confinement length is near about 48, and the strong confinement length is near about 14. And from these, we conclude that if you have a semiconductor, already we know what it is, its effective mass of the electron and the effective mass of the hole. So we can calculate what will be the confinement of the electron or hole inside the material. So what it happens due to the confinement? They become the complete insulator because electron is not free or even hole is not free. So that makes the material as a insulator.
Dear friends, I Dr. Manoranjan Kar, Department of Physics, IIT Patna. Here I will say about my work at IIT Patna and other places and what I have achieved till now, professionally as well as personally. In a nutshell, if I look to my CV and in the department, and since 2008, in every semester, as a passion of my teaching, I take the leading in teaching by offering highest number of hours from the department. Every semester, by some means, I get the highest hours for the teaching, and that I enjoy. Not only I have achieved that by keeping my goal, also I can say that I have contributed to the department by publishing so many international journal papers from IIT Patna, which has helped to IIT Patna towards its ranking. In one of the meeting also it was appreciated that from the contribution from the Department of Physics was from my group. That also reflects, and I have produced till now lots of teachers who has done the PhD under my guidance. They are working in central universities, state universities, as well as technical institutions. Also, I have graduated 5 students in MTech, Nanoscience and Nanotechnology. They are also good achiever. They are working in different places. I am very happy with them, with my students. Only for them I have achieved the milestone by publishing more than 65 international journal papers, more than 80 international national conference proceedings, as well as they have helped me a lot to present invited talks, more than 30 at the different places in the country. Also, I have attended lots of conferences in abroad. That experience helps me to teach my students as well as guide them in the research level. Right now, there are 8 research scholars are working under me. Although I got every day the approach, but I am unable to pass the message, or I am unable to guide them. So that is my achievement. I have made a very good group so that people are looking at our research and they are approaching and to do the paper that I feel it is a great achievement. Similarly, there are lots of summer students visit to my group, and unfortunately I have to say no to lots of students because of the constraint of space and other things. So in that way we are very happy, and I am very happy with my groups because we have created an environment where we can learn physics, teach physics, as well as leave some message on physics. that I feel it is my achievement, and beyond that, actively I was involved to develop the BTech laboratory at IIT Patna, as well as I have created a microscopic lab at IIT Patna with the help of other members of IIT Patna. As well as we have developed a laboratory where both spin polarization and charge polarization can be measured, as well as the electrical transport properties, VI characteristic, etc. are developed at IIT Patna under my supervision, and which is successfully running. Beyond the IIT Patna, while I was in Nano Center at IIT Guwahati, center was building up, and I leave a milestone by purchasing lots of equipment, install it, and demonstrate it to the users. And for that I got lots of appreciation from the center people. Beyond that, while I was a student, also I developed a magnetism lab at IIT Guwahati. Till today it is working. Some of the experimental setup was developed by me. Although I am a physicist, it is my passion to develop the experimental techniques. So in that way, in IIT Guwahati, it is working finely. Always I am in constant touch with them. Always they appreciate that whatever I have developed till now, it is working. That does not stop my achievement throughout my student career till my PhD. I was a student leader. That also different places my name has been written in the board and etc. That was also another achievement for me. Not only I am a physics teacher, also I was the student leader throughout. That quality drive me to carry lots of administrative positions at my profession, starting from IIT Guwahati to IIT Patna. Since 2008, either way I am in the administrative position, but always I make sure that that does not hamper my achievement of as a teacher, as a researcher, as a scientist. I keep balance between both the things. So that way I am very happy that I have achieved what I can be, but a person cannot say that he has achieved 100%, so a lot is in front of me to go ahead. And I hope I have told about what I have achieved. It is very difficult, as every day I create the history, or I create something odd to my CV. It is very difficult to compile within short period. And always there is a link in the internet, in different places, where one can get all the information what I have published, what I have taught, and what I have achieved. Thank you very much.